8.3 Joints and types of joints. The bones in our body are joined to each other by ligaments. The place where two or more bones are joined to each other is called joint. It is due to these joints that we can move our hands, feet, fingers, etc. The joints are of two types. The bones in our skull are tightly fitted into one another and they do not move. Such joints are called as immovable joints. The joints where movement of bones is possible are called as movable joints. According to the articulation of bones, the movable joints are classified. The ball-like end of one bone is fitted into the socket formed by the other bone. The bones can move freely in two or more directions. Shoulder and hip joints are of this type. Hinge joint. The movement at this joint occurs only in one direction, like the hinges of the door. The elbow joint, knee joint, and the joints in our fingers are of this type. Gliding joint. In this type of joint, 15.5 Let's make a magnet. We can make an iron object to behave like a magnet by following a certain procedure. Fix a powerful magnet to a stand. Fix an iron strip at a short distance below this magnet. Now take iron filings near the iron strip. You will find that iron filings stick to the iron strip. Thus, the iron strip behaves like a magnet. A magnetic material acquires magnetism when placed near a magnet. This magnetism is called induced magnetism. When a bar magnet is moved away from the iron strip, then the iron filings fall down and do not stick to the iron strip. Thus, magnetism in the iron strip vanishes. This indicates that induced magnetism is temporary. Take an iron needle or a nail. Place it on a table. Now rub it with a magnet from its one end to another. Do this 7 to 8 times. Now take a few pins near the nail. You will find that the pins are sticking to the nail. Thus, the nail acquires magnetism. This magnetism is also temporary. Take an iron nail of about 5 to 10 centimeters long. Wind about 1 meter long insulated copper wire around it. Connect two ends of this wire to a dry cell. Now, take some iron pins near the nail. What do you observe? You will find that the pins stick to the nail. When electric current starts flowing through a copper wire, the iron nail acquires magnetism. As a result, the iron pins stick to it. When the dry cell is removed from the circuit, the pins sticking to the nail fall off. Thus, magnetism vanishes when electric current is switched off. Such a magnet is called as an electromagnet. Electromagnetism is temporary.